And that was the inputs, and then they had it all labeled. They had birds flying around and people walking and other tanks driving and so on. And I had to come up with an algorithm that would automatically distinguish between the birds and the other tanks and so on. So I spent a whole summer doing this with my 20,000 data points. And in that summer, I came up with different algorithms, different variants of genetic algorithms and neural networks and so on. And I managed to reduce the error from 45% to 35%. So that was my whole summer's work, improving the error. Maybe it was even 25%. So good for me, right? 1 in 4 times it still fails. And that was my summer's work. This was in the late 90s, and guess what? This was the standard way you did things in the 90s and even most of the 2000s if you're in AI. You have a fixed data set, and you basically you hide in your room for a month or a full PhD, and you come up with your most accurate model, right? And then you publish a bunch of papers, and you get your PhD and so on. And the stuff promptly doesn't get deployed, right? So what I did, 25% error, that's unusable, right? You really need 5% or 1% or 0.1% error. So, but there was a trickle of information. Some researchers started thinking differently. And what they thought was, and these researchers here at Microsoft in early 2001 said, what if we just kept the same old algorithm, maybe even a stupid old boring algorithm from the 50s or 60s, like k nearest neighbor, like just looking at the 5 nearest neighbors and then classifying from that. So they did this, and they had some other boring old algorithms too, like naive Bayes, which doesn't even care about how variables relate. And they said, what if we just add more data? So we don't need to have some PhD locked in a room for 4 years. We just give it more data. And they did this. And in this case, they were doing a language task. So initially, if you looked at publications before this 2001 paper, you would see maybe 4 data points, right? It's like, here's my naive Bayes, actually this one, here's my KNN, and so on. And they would just be competing. OK, I'm 5% better than you, right? But if you look at it, they all suck, right? They're all terrible. It's all like 17% error at most, right? But, and this is kind of where everyone is competing in their conference papers and so on. But, what if you actually had more data? So 10x more data, 100x, 1,000x, 10,000x more data. What happens? The accuracy goes up, 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 up. Or error goes from 17% all the way down to 1% just by adding more data, right? If you think about this as an AI researcher, it's super embarrassing, right? A bunch of CSV files can do more than a summer or a PhD worth of research, right? So AI people don't really like to advertise this. But what it points to is the unreasonable effectiveness of data, right? So in this case, 1,000x more data gave 1,000x less error, right? And so what that led to is, by the mid-2000s, Google researchers and other companies like Facebook and so on started realizing this and just going like crazy. And deep nets, all these sorts of things, took it to the next level because you could have the capacity to have massive, massive data sets, 100 million, 1 billion, 10 billion data points, and just learning on it, thanks to Moore's law. And what it's led to is, well, you have a bunch of companies, not that many, a handful actually, that are really awesome at gathering the data, holding it in these massive silos, and then extracting value from it with AI. What sort of value? Well, if you're Google, you take that data, you build a model that makes it's more accurate than before because you have more data. You use that model to sell ads. So higher click-through rate, more money, right? That's what Google does. That's what Facebook does. In Amazon's case, it's basically to give better recommendations, right? It's uncanny, right? I was actually on Amazon this morning buying some USB chargers, some lightning chargers, and then it recommended, hey, why don't you actually have this, this plug-in as well, right? I'm like, actually, that's a good idea, right? So it is really good. It's like it's read my mind, right? It's probably almost better than my wife at recommending this stuff. So certainly better than me. So that's actually really scary, right? And they're making more money, right? Amazon made more money from me today because it has really good AI, right? And this is what's happening. So we have all this, these companies that have become incredibly powerful, incredibly wealthy by massive data sets siloed up, right? So we're in this new data economy for our data society. But the power is in the hands of a small number of organizations. Here's a stat that scared the heck out of me. I don't know if you guys can read it well. It's OK. OK, I'll read it out. Google and Facebook now have direct influence over 70% of internet traffic. 70%. That was a stat from an essay published a couple months ago. The title of the publication is "The Web Began Dying in 2014." So, well, that speaks volumes on its own too. And there are a whole bunch of other stats that people have been starting to notice in the last 1 year, 2 years, 3 years that is really scary. It's not just scary because of the power accumulated into these companies, but keep in mind, remember the Snowden revelations? Prism, all that? Prism never shut down. Google has been supplying data to the US Department of Defense, the NSA, all these guys, since 2012. Microsoft since 2007. So all that data that Google is gathering, guess what? It's all in Prism too, right? We are in a surveillance state, make no mistake, right? And more recently, I don't know if you guys saw the news from 2 weeks ago, there was a reporter from National Geographic. She was writing a story about some wildlife crimes, right? And partway through her story, her Google account froze up. And she's like, what's going on? So she tweeted, what happened? It happened to a bunch of other people too. What was happening? Google algorithms had a glitch. And the glitch detected that she was breaking the terms of service. Somehow, some crime that she was committing, writing about a terrorist act or something, right? And then they just shut her out, right? But if you think, and then Google said, oh, we fixed the glitch, we fixed the glitch, which means they have a more accurate model to detect whether you're a terrorist or not. So does that mean I actually can't write a term paper talking about Al-Qaeda? Does that mean I can't actually write an article and complain about the government? I can't organize a protest against the government? This is a direct assault on our democracy, on our freedom, right? This is super dangerous. This is happening now. Keep in mind, every time you use Gmail and type things in, you are being watched, not just by Google, by the US government. And Google can shut you down like that. This scares me. So we have these data silos, we have this people farming, and we have this threat to freedom itself. There's a way to frame the core problem, right? And my friend Lawrence Lundy with Outlier, many of you might know him, he summarized this problem as you have siloed data with no economic incentive to share. And you can break that down into 2 parts, siloed data and, well, no economic incentive to share. What I'm going to do now is talk about what we can do about this. Because we can say, oh, this is terrible, let's go run for the hills and hide, right? But we don't want to give up our cell phones. We don't want to give up our digital lives. We don't want to go back to a life expectancy of 30 years, right? No, we want to have our cake and eat it too. So maybe there's a way to do that. And let's talk about that. So first of all, what can we do to break down these silos of information? Well, to start with, you have to ask yourself, right now we've got Google and Facebook and the like, and they've got amazing AI expertise and amazing data. But what about all the other enterprises? They actually have tons of data too. It's just sitting there, gathering dust, latent, right? They want to hire AI experts, but it's really, really hard because they're stodgy old dinosaurs. And all the AI experts, you know what they want to do? They want to start startups and make money, or join Google for a $2 million signing bonus, right? And that's what's happening. So on the flip side, you've got all these AI startups, right? And there's all these researchers with lots of ideas, and they know how to use this data and turn it into digital gold. But they're starving for data. So they have their fancy algorithms. They've got 25% error, 10% error, but you can't build a product from that. You need 1% error, 0.1%. So you've got, on one side, these enterprises that are starving for AI expertise, and on the other side, these AI folks that are starving for data. Let's connect them, right? Let's have a medium to connect them. And maybe not just one medium, but a whole bunch of mediums. What is that? Data marketplaces, right? Marketplaces where you can have the buyers and the sellers come in. And you don't want just one storefront, right, sitting there in the middle of the desert, because that would be centralized on its own. You need a whole bunch of them, right? And different ones competing for IoT data and competing for personal data that people can buy and sell if they choose, and so on and so forth, right? But then, if you think about it, if you have different storefronts selling different data, you have a liquidity problem, right? Because each data set on its own is going to be just locked into that one store. So what you need is you need a common substrate that any one of these marketplaces can tap into and sell. That's what Ocean is. Ocean is that common substrate to unlock the data sets to be bought and sold on the data marketplaces, sitting side by side with the global data commons. So we've got the priced data, the for sale data on one side, and the free data on the other side. And overall then, it's actually about unlocking a data economy. An example for you guys is the following. If you ever go into, say, kayak.com and you search, right, you'll get a bunch of results from different airlines, right? I'm flying to New York shortly, so I have results from everything from Aeroflot to WoW Air and all of this, right? If I go to wowair.com, I'll get exactly the same results just for WoW Air, right? With a completely different interface, by the way. If I go to Expedia, it's the very same results, right? They're all tapping into the same database. That database is called Sabre/Amadeus, right? So basically, in the travel industry, we actually have a common database that all the online marketplaces use. It's a data substrate for just airline data, just selling that. It's centralized, but it's actually caused this unlocking of data sets, data marketplaces above. Ocean is Sabre for data itself. That's what Ocean is about. And of course, it's decentralized. I mean, otherwise, what are we doing, right? So that's what Ocean is. It's basically driving towards the pooling of the data, helping to unlock the data marketplaces where you still maintain high liquidity via this data substrate. So that was the first challenge, right? Getting rid of these data silos and instead encouraging the data to get pooled together. But there's a second part. How do you incentivize people to pool this data, right? What do you do? And so by a bit of background, in the beginning, there was Bitcoin, right? And many of us probably have been following Bitcoin since maybe even 2008 if you're really on top of things, but 2009, 2010, and so on, right? But in the beginning, there was Bitcoin, right? And obviously, it's changed a lot of things, $100 billion plus economy, and so on. And of course, the technology below is blockchains, right? And we sort of saw the rise of blockchains in 2014, 2015, 2016. And the amazing thing about these, there's quite a few very cool features, right? They're decentralized, right? No single entity owns or controls, sort of public utilities. They're immutable. Once you've written to it, it's there for good, right? For really good audit trails, all that. Aligning incentives, you have this whole community pointed in the same direction. Great. Or, if you've got a white paper and a dog, maybe you can do your ICO, right? So, and of course, there are good ICOs too, but some of them, well, that's for another talk. That's for upstairs, right? No. Anyway, so basically, there's a lot of really cool thing about blockchains, but there's one more that hardly anyone ever talks about, right? What is it? It's actually the not so obvious blockchain superpower. It's maybe the most powerful one of all. With blockchains, you can get people to do things, to do stuff, right? How might that look? Well, you have to come up with economic incentives and bake it into the network as block rewards, right? So once again, with blockchains, you can get people to do stuff. Let's look at what this means. Let's use Bitcoin as an example. So inside Bitcoin, what is Bitcoin trying to do? At the core, it's basically trying to store this log of transactions, right? It's just a pure play blockchain. But it wants it to be as secure as possible. It's trying to maximize the security of this list of transactions, right? It's just this big, huge transaction log, right? So it defines security as compute power. And then it says, if you have security defined that way, it means it's super expensive to roll back changes on the transaction log. Expensive as in compute expense, right? It's actually a democracy where every individual is an electron, right, in a sense. So what the formula for block rewards is, the expected value that your block reward is proportional to your hash power of the actor, and then the number of tokens dispensed each block, right? Right now, you get 12.5 Bitcoins every 10 minutes, right? So that's the economic incentive. That's the block reward for Bitcoin. Straightforward. Maximize the security of the chain. To make it a bit simpler, you've got these Bitcoin mining rewards, this economic incentive. You get block rewards if a couple things happen. You're running a full node, and you have gobs of compute power. You don't need gobs, but then the probability of actually getting reward is less than the lifetime of the universe, right? So I could, maybe this laptop is a full node, but good luck actually getting something. Or you can pool it and so on. But overall, if you have gobs of compute power, then you might have a chance. And this causes people to do really amazing things. We've seen the rise of ASIC farms where people spend $100 million to design and manufacture that chip on the most modern process, right? TSMC, 11 nanometers. What we have behind here is actually one of those mining farms, right? One of these super advanced farms. And overall, the amount of mining power going into Bitcoin these days is more than the top 500 supercomputers combined, right? That's pretty secure, right? And basically, that comes down to the single objective function that Bitcoin had. Just as a quick aside, I spent a long time in AI, and part of that was designing evolutionary algorithms. And I've come to realize that design of these tokenized ecosystems, these public utility networks, looks a lot like design of evolutionary algorithms. So on the left side, I talk about the ecosystem. On the right, you've got the EA. On the left side, you've got a block reward function. In an evolutionary algorithm, it's an objective function. So you're trying to minimize or maximize something. Maximize hash rate versus, say, minimize error in, say, training a neural network, right? In blockchains, you've got miners and token holders. These are humans in a network. In an EA, you've got individuals. These are basically computer agents running around, right? And they're in a population, right? So once again, similar things. You've got a block reward interval. You've got a generation. Every interval or every generation, you kind of update. You give tokens, all these sorts of things. And in a tokenized ecosystem, you can't control the human. People will run around and start mining pools and start ASIC farms and buy and sell Bitcoin. And all you can do, though, is you can reward them for doing the things you want them to do, give tokens. And you can potentially punish them for doing things you don't want. In proof of stake systems, it can be like slashing stake, right? Or you can also punish people for doing bad implementations by hacking, right? Every blockchain has a built-in bug bounty system, right? Kind of amazing. Bitcoin is a $130 billion bug bounty system. Pretty cool, right? And on the side of EA is similar. You can't control these individuals. They might mutate. They might cross over. You don't really care. They do what they want. But what you do is you reward the ones that do well. You let them reproduce and have babies, right? And if they do bad, they're dead. They're gone, right? So basically, there's a lot of similarities between these tokenized ecosystems and EAs. And what's cool then is all the knowledge that has been developed here since the 60s when genetic algorithms were invented by John Holland, and actually independently here in Germany too. All of those ideas, you can actually start to apply to tokenized ecosystem design, right? So let's talk about economic incentives for Ocean. What is it that we're trying to do with Ocean towards addressing these issues I talked about? Overall, what we're trying to do is maximize the supply of high quality data, or to be more precise, to maximize the supply of curated data. We leave it up to the agents out there, the actors, to curate, to choose what's good and what's not, right? And so overall, what this means is that you're rewarding people who are curating data and making it available, serving it up, et cetera, right? What does curating mean? It means betting on the data itself. And this is via a curation market invented by Simon de Louvier, leveraging that, right? It's sort of like you have a mini ICO for every single data set, right? And so if I'm early in this, the very first person to serve it up, like to make it available, sorry, or if I am right after that, it costs me less to invest than later on. So, and basically, therefore, you're rewarding the tastemakers, the early adopters, and so on, right? So overall, then, the formula is the following. The expected rewards, right here, is proportional to the stake in the data set, right here, and the popularity, right? So you need people to predict that something will be popular, bet on it, and it actually needs to be popular. When those two stars align and you serve up the data, that's where Ocean comes through. Another way of thinking about it is it's a curated, it's a curation market with proof of work, a proof of work curation market. So we've got the betting on the data, the actual popularity. This is the token rewards per interval, sort of like every 10 minutes for Bitcoin. And then finally, this is a download ratio. There's a particular attack. If someone uploads something and then it lets themselves, then that's a problem. So there's just a download ratio of uploads versus downloads. So overall, that is the trick. Now, you might notice a couple things. I won't go into this, but we can talk after in questions. There's a log on this, and there's a log on this. You might ask why. What's going on there, right? Well, this actually comes from tricks in the AI world. If you have logs here, then it actually focuses on the order of magnitude instead of the fixed value. And humans themselves reason much more in terms of orders of magnitude. They think about increase in percentage up and down. The other thing that it does is, if you don't have this here, these things, what you're going to have is someone uploads a data set that becomes super, super popular, and everyone just bets on that. But when you have the log, it means that people have to spread out. You have to have diversity of data sets, right? Because basically, you can only get so many rewards for one data set. If you want to get twice as many rewards, you actually would have to put in 10x the stake. If you want to have 3x the rewards, you would have to put in 100x the stake. So you might as well actually stake a whole bunch of data sets, right? So it's implicitly encouraging diversity of data sets, which is actually what we want, right? So to kind of summarize, with Ocean, the mining rewards are, you get block rewards if A, you've bet on a data set, and B, you've made it available when asked, right? And sort of made it available when asked, this includes the popularity part then, right? And of course, like any tokenized ecosystem, blockchain network, it's got a bunch of miners. We like to call them keepers sometime. And the main blocks inside are, there's a core proof. Every single blockchain ecosystem needs a proof in there. Bitcoin has proof of work, finding the nonce. Filecoin, when it deploys, it will have proof of spacetime to sort of prove that you have stored that data for a while. Steemit has proof of human work, where you contribute. It's proving that you have contributed interesting pieces in a medium-style way, et cetera, et cetera. So in the case of Ocean, it's actually proving that you have served up the data to make it available. It's a bit like Filecoin's proof of spacetime, where you have the data, except it doesn't really care where you stored it in the past. You can copy it last minute from S3. It doesn't care, right? So that's the core proof. And then some of the other main building blocks, you've got the block rewards mechanism, you've got the curation market. And there are several possible attacks where people can be bad actors. So we need to have an actors registry. And this is drawing from AdChain. It's called a tokenized, well, it's a tokenized registry. And basically, to be part of the ecosystem, to submit data, you need to submit stake in order to be there. And there's a vetting period. And during that time, people can vote for you or against you. And if they see you as a potential good actor, they will let you in. They are incentivized to have good actors because that means the tokens will rise in value. And conversely, they're disincentivized to have bad actors. So that's what this is about. But at the very, very core, it's really about the curation market with block rewards. And then everything else is machinery to support that. So in terms of applications, we started work on this actually. Well, we started thinking about it a lot late last fall. I published a couple blog posts, one on blockchains for big data. In that case, the main conclusion was, oh, wow, data marketplaces are really important. That's a linchpin. A couple of months later, I published a post on blockchains for AI. Once again, all roads led to data marketplaces. So we started to go down that path. And in early 2017, we iterated with DEX on a data marketplace. And in building Ocean, we were actually working with DEX. DEX was a centralized data exchange out of Singapore. Now we're working with them to basically have a decentralized data exchange protocol. So Ocean itself is not a data exchange or data marketplace. It's powering them. It's one level lower. Another one, though, another partner that we started working with and announced in May is Toyota, Toyota Research Institute, to be precise. So this is the research arm of the world's largest car company. And they saw that in the world of automotive and cars, in USA, there are more than 1 million deaths per year from car accidents. And the leading cause of this is human error, right? We suck at driving. We've only been doing it 100 years. We didn't evolve for it. So we crash into each other and kill each other, right? So people have seen that if you have self-driving cars, you can actually dramatically reduce that error rate. And the challenge is, though, the algorithms are there, but you need more data, right? And so McKinsey calculated you need about 1 trillion miles driven. Toyota realized, oh, wow, we could try to do that ourselves, but it's going to take a long time and cost a lot of money. But guess what? Daimler wants this. Uber wants this. Mercedes wants this. I mean, that's Daimler, sorry, Volkswagen, et cetera, right? So what if you could pool your data, all of these car companies together, and everyone shipped this stuff sooner, right? That's a win for the car companies, and it's a win for humanity, right? The thing is, they're all big enterprises. It's not like they're all going to sit down and hug and sing Kumbaya, right? So they can't just pool. You need some sort of economic mechanism for them to work with each other. And basically, that's what a data marketplace is about. So with Toyota, we actually built a prototype data marketplace just to get a feel for this. And then basically, we announced this at Consensus in May. And we have continued iterating with Toyota since then towards this goal, and also in talks with some other automakers. So some overall applications, what unlocking data unlocks with Ocean. The main thing is equalizing the opportunity for access to data and access to the benefits of AI. It's about democratizing data, right? That's the high level. But then a key thing is this is actually squeezing out the data silos, the people farming that's going on, the complete risk to the future of society and freedom, right? So this is the main thing ultimately, right? But of course, there's other things. A sister company of DEX is actually doing Parkinson's research based out of Munich. And just like my experiences from my very first job as an AI researcher in the 90s, they are usually working with very limited data sets. You're trying to build a model of whether or not someone might have Parkinson's in the future, right? But if you only have 10,000 data points, your model is limited. What if you have 1 million data points, right? The challenge is these silos all over the world. So is there a way to basically mine the data from all of these different silos, yet at the same time preserve privacy? And the answer is, these days, yes. You can bring compute to the data. You can even let the data stay encrypted using tools like homomorphic encryption. And these things overall basically can unlock a win-win situation where scientists can actually build really great models for early detection of cancer and Parkinson's and so on. And at the same time, you can retain privacy. One final example I've talked about already, self-driving cars for fewer accidents and more mobility. People who maybe couldn't drive, now they can get around more easily. So to wrap up, we've lost the web, right? So let's reclaim it and make it better. Let's build a new data economy that gives power to the people. Thank you. Questions? Yeah?
Sure, just a few questions.
Okay, go ahead.
Maybe one question. So if I own data, how do I install an Ocean node, or how do I actually interact with Ocean then, and what? Can you repeat the question?
Oh, sure. So the question is, if I own data, how do I basically get it into the system? How do I interact? Do I install a node, et cetera? So there's a few mechanisms. At the core, Ocean is its own network, right? Just like Bitcoin or Ethereum or IPDB and so on. Generally, for the end users, you shouldn't have to install a node. You could be going through a third-party client, think like a wallet or whatever, or some web API, some web page. And you're probably going to be going through a data marketplace. Dex is standing up a data marketplace. We're also iterating with many other companies that are building their own data marketplaces, centralized and decentralized. So most of the time, you would be just iterating with one of these, with Dex or otherwise. You wouldn't have to iterate directly. If you want, you could put your stuff into Ocean directly, but Ocean itself isn't designed for pricing, right? The pricing happens at the marketplace level. Ocean itself, at the very, very core, it's simply a curation market for data with a sort of proof of work attached on, right? So it's basically a curation proof network, if you will, or a curated proof network.
So may I ask just,
yeah.
So I give away my data. I have to trust the data marketplace of FTX or whoever provides that they don't mess around with it, or?
Not necessarily. So, I mean, those marketplaces, some are decentralized, some are centralized, right? So you are making a claim on copyright when you submit to the marketplace or to Ocean directly. And that claim, there's actually proofs around that too. I won't get into that. This goes back to even our Ascribe days where we did sort of copyright stuff. But you're putting it on there, you're making this claim, and people will vet that claim. And if you have decentralization at the level of marketplace, then they can't really act badly because someone will call them out. And also at the Ocean level, it's decentralized, so whatever claims you're making are going to get recorded as well, right? So.
Maybe discuss it.
Yeah, sure. There's a question back there for.
I have another question which relates to the question before.
Uh-huh.
So technically, if I'm giving away my data, where is my data then stored? Is it marketplace? Is this just a linking system to my data?
Yeah. So the question is, if I'm giving away my data or selling it, where is my data being stored? And it's up to you. So Ocean does not store the data. Ocean is basically a layer to curate and give tokens to reward people to incentivize them to share data, right? So Ocean is incentivizing the sharing of data, making it available. You have IPDB, basically big chain DBs, public net, storing the metadata, which is like who owns it, the claims, all of that. But then the data itself, it's up to you. So you have a few options, right? You could store it on-premise behind a firewall, encrypted if you want. You could store it on a cloud like S3, or you could store it on a cloud decentralized like Filecoin. It's up to you. And there's certain things that it would be a bad idea to do, right? So for example, if you've got medical data, you shouldn't be putting it on the cloud at all, even on a public net encrypted, because when quantum happens, in 5 years, 10 years, then it's all free and in the open, right? So yeah, does that answer your question?
Yeah.
Okay. And then sometimes, right, if the data is on the client side, still like staying where it is, you can bring compute to the data, and it looks basically like a fancier data query, right?
When I upload my data to some host
Yeah.
somewhere, and I get my reward for giving my data away, what
Yeah, so you don't get rewarded for making your data available. The block reward. If you upload or if you make a crappy data set available, someone downloads it, they're like, this is a piece of garbage, I won't bet on it. So basically, there will be no, like, the price of that data will be super low, like no one will care. And price as in the betting, like it's free for anyone to download the data, right? Yeah. There's another question here. Go ahead.
So I was wondering in terms of, maybe it's taken care of with the active registry or the curation markets, but the incentives around kind of sharing anonymized or encrypted data and how you make sure, because better data doesn't necessarily mean encrypted or anonymized data. So like what are the incentives to share properly, like in terms of like not wanting to share something on the cloud, like are there incentives if it gets past the registry? You know what I mean?
I know what you mean. So the question overall is, are there incentives above and beyond just the sort of popularity of the data for things like privacy and so on, right? So one thing, overall, we're trying to basically push that to the users as much as possible to think about, because otherwise it gets crazy, right? So we want to have a very simple system. However, one thing that we see that will be an additional feature, we have a white paper that will come out not right away, but in coming months that talks about this in detail, is labels. So you can basically have data itself that's labels, and then there will be curation markets on the labels themselves. And it will be a label attached to a data set. And then people can basically bet on whether they think that label is valid or not. And once you have labels, you can have labels saying, this needs to be on German soil. This is health data. This should never be on a public net. And then with that, because there's an economic incentive to get that right, then a lot of powerful things will fall out. Another really cool benefit of the labels is you can actually have emergent hierarchies, essentially subreddits for given groups of data sets. So labels buys you a lot in terms of privacy, annotation, security annotation, and just sort of navigating and discovering data sets. More questions?
About the logarithmic function in the profits. So isn't there a civil attack possible by me publishing, let's say, two very similar data sets, and then I earn twice, so the logarithm becomes useless?
Yeah, so if you publish two similar data sets, before you would have had, if you have just one data set, then a bunch of people would vote on just that data set, bet on it. If you publish two, then maybe if they're equal, people might just put half their stake in one and half in the other, or they might just put all their stake in one, right? But of course, people are going to be commenting on this, labeling it, and so on. So over time, people aren't going to want to deal with the data sets you submit because they're kind of dishonest, right? So the market will essentially take care of this. Yeah, sorry, I should have repeated the question. The question for that was, if there's someone publishing very, very similar data sets, then isn't that like a Sybil attack? And yeah, the answer is it's basically they're spreading themselves thin. So question here.
Seems like with the active registry, what you're solving is Sybil attacks, because you say if I want twice as many rewards, then I need to put 10 times as much stake. But if I could create two identities, then I could just put twice the stake, right?
Yeah. Yeah, so to that question, just for everyone's sake, so the actors registry is to solve certain classes of Sybil attacks, and that is exactly one of the main reasons for it, yeah.
And so that's great. If you apply that to like proof of stake, then you could like unit stake in proof of stake systems.
Uh-huh.
And what's the kind of trade-off with that?
Well, this is a proof of stake system.
So what's the trade-off in having this actor registry to use?
Well, so yeah, so overall, so if we had an actors registry versus not, so if we didn't have one, then a bunch of the sort of mechanisms that we need in order to avoid attacks wouldn't be there, and we'd have attacks that could debilitate the system. By having it, there is a trade-off, and that is it's an ad chain style way of entering. So what that means is if you want to enter and start using the system, you have to stake some tokens, and then there's a vetting period. Right now, we've set it to 28 days. We'll see when we release. And during that time, other people can say, oh, yeah, he's good, he's not good. And if someone wants to vote against me, they put down stake and vote against me. If someone wants to vote for me, they put down stake. And after those 28 days, it all gets tallied up. And if all the votes are for you, like if the majority is for you, the majority of votes, then you're in. And everyone who voted against you loses. And vice versa then too. So if the votes say you're out, then you lose your stake, and all the people who voted for you lose your stake. So that would be, I think, did that fully answer? I think I'm missing something. Oh yeah, there's a second piece. So this is friction to coming into the system then, right? But what if, say, you know, can we overcome that somehow? And so what if I'm already in the system, I'm in the whitelisted actors registry, and I know you. And I'm like, hey, I trust you. You know, you should come in and trade data. And you're like, yeah, I know, but I've got 28 days. I'm waiting. So what we're currently planning to do to address that is something from the Open Bazaar system called trust as risk. And what that means is I'm vouching for you. I'm putting ocean tokens worth of stake to vouch for you, and then you can join. And at any point in time for the next 28 days, whatever, you can grab the tokens I put there and run away, right? So I'm trusting that you're not going to do it. So I'm essentially vouching for you with my tokens, right? I'm putting my money where my mouth is about your reputation. So that's basically helps to remove the friction for onboarding. I'll just take one over here to mix it up. Go ahead.
Yeah. I have a question regarding the proof of work. Like I cannot draw the parallels from how Bitcoin is maintained. Like you solve hash over there. Here, the miners actually solve the betting system basically.
So overall, it's basically the work that is being done is making the data available. It's spending bandwidth to basically make that data available, as well as getting that data from somewhere, maybe storing it, and then putting it out there and proving that you had that. But basically, it's making it available by hell or high water, right? So that's the overall, I guess the question for everyone, you know, if there's proof of work or proof of stake, what's the proof, what's it doing? And the answer is, it's proof of availability, proof of making data available by serving it up, whatever. So that's the main work that's being done. There's also a kind of a softer proof, which is actually proof of claim that you have the rights to put this thing up there, right? And that's softer, it's harder to solve. And within that, what we have is you're making a claim. Well, first of all, there's the actors registry, so you have a bit of a vetting there. But then when you upload it, you're actually making a claim of copyright. And if other people can make, once again, claims against that back and forth in sort of a challenge response mechanism, like TrueBit and others use. And that still leads to a few possible attacks. So you still need sort of a last resort system. And that last resort system is basically third-party arbitration. And what we're going to be plugging in there, we're right now iterating with the folks at Ethereum, Vinay Gupta and those folks, where basically, if all else fails, you still have legal recourse. And this is actually really, really useful because if people know that even if they kind of game the system and hack it in some way, if they sign up to use this system, and they abuse it badly, there is still the full weight of the world's legal system against them if they act badly. And so it converts what would normally be a zero-sum game in the network to a positive-sum game, right? And this is what Ian Grigg writes about in the Blockchain Constitution, what they're building into EOS, for example. And actually, Cosmos has some of it too. So kudos to Cosmos. Question back here.
You said that people start downloading the data then, and can you explain how data ownership is tracked or maintained then? So
Yeah.
what keeps me from downloading and populating it on my own and saying here's the data?
Yeah, so overall the question is, can we track how the ownership is tracked? What stops him from downloading the data and making it available again, right? And I'll break that into two answers as well. So when you upload data, you are making a copyright claim, and that claim is immutable, right? And if you're actually making a false claim, then ultimately you have the full force of the law. But of course, you don't want to say, okay, some tiny flip of switch and suddenly you have this army of lawyers against you, right? So you really want sort of sunny day tech, rainy day law, right? So the vast majority of the time, there should be incentives within the system to resolve itself. And this is where basically you have, whenever you upload the data, people are actually vetting that data to see, do we believe that this actor has put something in that's good or not, right? So, and if they believe that you've done something maliciously, then they can kill your stake and you actually get booted out of the system, right? So that's the current design. And overall, if it's found that you've used this data that isn't yours and gained from it, then it can end up in a court of law, right? So we actually do have the legal recourse once again. Not most of the time, right? We're really trying to have good defaults to just leveraging the economic incentives.
So I get punished when I post the same data again? Is that what you're saying?
If you don't have the rights. If it's public domain, it doesn't matter, right? But if you download data and it's public domain and you make it available yourself again, then people are going to be going for that first data set because it's already got all the popularity, right?
And the other one?
Sorry?
If it's not public domain?
If it's not public domain, well, that's the first part of my answer, right? Where basically it means that you're actually violating the law, you're committing fraud. In some countries, that's jail time. So have fun with that. Question?
So I actually have two questions. So first is, how do you track downloads? So the only way to download the data will be through the network. So you upload it somewhere, but the location is only known to the network somehow, and then the node proxy the data and can be downloaded, right?
Well, I can answer that. So maybe I'll answer, then you'll ask the second part. OK, so the question is, how do I track downloads, right? And overall here, it says, it doesn't say the reward equals, k times this times this times this. It's the expected reward, right? And this is exactly like Bitcoin. So here we take the idea of stochastic payments, just like Bitcoin. So the initial system that we actually designed was tracking all the things, and there's all these messages flying back and forth, right? But that gets, you have this just explosion of messages. It's O to the n squared and the bandwidth being used, right? But Bitcoin, it has a really sneaky answer to this. And by the way, if any of you guys just do token design, you'll find yourself keeping going back to the Bitcoin paper. There was a bunch of super sneaky things that Bitcoin did that only someone with experience would have known. Someone who would have done digital cash in the 90s or whatever, right? So in this case, the inspiration from Bitcoin is the stochastic payments. And so Bitcoin, if you look at the formula for Bitcoin first, right? The expected reward is just proportional to your hash power, right? But that doesn't mean every 10 minutes everyone gets a fraction of Bitcoins. No, one entity gets a bunch of Bitcoins, right? And the dice gets rolled, and basically your chance of winning is proportional to your hash power, right? So, but only one winner comes out. That's why you have the expected. It has high variance, right? But it's still the same expected value. If you want to smooth out the variance, that's where the mining pools come in. So you let the mining pools emerge on top. That's exactly what Ocean does too. So here, we've actually got expected value. It's not, R equals K times. It's just expected value. It's stochastic payments. Mining pools will emerge on top. And then it actually resolves all of these bandwidth issues. They just melt away. So thank you, Bitcoin.
But the downloads go through the node.
The downloads do go through that node. Yeah, and it has an additional benefit here, which is really, really cool, right? If you have a bunch of different parties betting on data because they think it's great, it's an automatic CDN, right? A content delivery network. It just adapts to more and more popular data. So if there's a super popular data set and 1,000 people are betting on it, they're all incentivized to serve it up so that they get their block rewards. Whereas if there's one really crappy data set that no one cares about, no one is serving it up, or maybe one person, right? So it's automatic CDN.
The second question is,
yeah.
I want to put a stake in a data set.
Yeah.
But so I can do it either on the reputation of the person who sells it, or I can actually buy it and look at it and see if it makes sense, right?
Yeah, and you can also see what the price of the data set is so far and stuff too, right? Or social signals on social media, whatever. Yeah.
Is there anything preventing the situation when I have someone new enters the market and I have no way of validating if the data is selling is good?
Well, you can download it.
I get them wasting money on it and it turns out bad.
Well, then why would you bet on it, right? You can and just take a chance, or you buy it, you vet it for yourself, right? So some people will take the chance. They'll just buy everything that goes for sale, and some is good, some isn't. So the market will sort that out. I should answer, the question was overall, how do I vet data that people have posted for sale, and I don't want to buy it? And what I'm saying is, you want to vet it, then buy the data. Question, sorry?
Maybe we can, take the rest of the questions after, and
Okay.
move on to the next.
Okay. Thank you very much, everyone. Good, yeah.
It's okay? All right. Yeah. Cool. Thanks so much for coming, everybody. It's been a while since I gave a talk here. I remember in the beginning I gave like talk every meetup, but yeah. So I'm going to speak about Cosmos today, and about the kind of different components of Cosmos, the thesis behind Cosmos, and some of the how it works underneath. Now this talk is called Many Chains, Many Tokens, One Ecosystem, which is kind of a description of this Internet of Blockchain vision that Cosmos has. Now, I must say that I have plagiarized this talk, and then the original author is a guy named Sunny. He's also the self-declared czar of Bitcoin Cash, and he, as you can see here, and he's been working at Tendermint as a researcher for a while, and he's first came up with this excellent talk, which I've only slightly modified. Yeah, so probably most of you, or some of you know me, so I've been around this space for a while. Started this meetup group like 4 years ago, and also run the Epicenter podcast. And then I was working 2015-16 for a company called Monax. Now Monax is actually building on top of Tendermint, and then since January I've been working for Tendermint and Cosmos. And some of you may know we did a fundraiser in April to raise money to build out Cosmos, and so that's what I've been working on since then. And next year, I'm actually going to start working, or we have started working on running a validator for Cosmos. So I'm going to leave the company now that's kind of building out Cosmos to run a validator in the network. Yeah, so there's two projects here that we should talk about. First is Tendermint, the second is Cosmos. So Tendermint is a much older project. And Tendermint really comes from kind of a different approach to building blockchain applications. So traditionally, the way blockchain applications have been built is by having kind of one software code base that is, the entire thing. So that includes basically the networking, so the peer-to-peer things of like sending around blocks and data, and the mempool and things like that. Then the consensus rules, so what are the rules for producing the next block? And finally, the application. So, with Bitcoin, very famously, it is one massive code base. It's very, very hard to change because they're all kind of interwoven, not clearly separated. And even with Ethereum, right, it's still one code base. So this is kind of how blockchain architecture has traditionally worked. Now with Ethereum, the problem with this architecture is, so if you want to like build an application on top, you have to like go deep into the sort of machinery of this thing and make changes to it. So that's why it's very, very hard to build things on top of Bitcoin. So you had these kind of clunky efforts like counterparty or colored coins to do things on top of Bitcoin. And of course, it didn't really work. And also, if one forked Bitcoin to do a new project, that's very difficult too. Or even just to write a client that's compatible with Bitcoin so that you don't accidentally fork, that's very hard, right? So today, this Bitcoin Core, which is basically run by all the mining hardware, is run on that. So still, there's only really one implementation of Bitcoin. And that has a lot to do with this and how this is built. And of course, they came Ethereum, and Ethereum tried to solve this problem to some extent by basically saying that the application isn't this limited thing anymore, but that the application itself becomes a virtual machine that you can then run full scripts on top. So this is basically the Ethereum stack. So you still have networking consensus and the virtual machine or the application here as part of one code base, but you can then write these Turing-complete applications on top of that. And of course, this was a very good idea and a brilliant idea, and it led to tons of innovation and progress and yeah, a whole ecosystem around that. But there are some problems with this. One is that as an application developer, you have no control. You can't really change anything underneath. So you can't change consensus and networking, but you also can't change the VM. So you can't really write applications in anything that doesn't compile into the kind of EVM bytecode. So basically Solidity and Serpent. I don't know what the latest other language is Ethereum has. So it's very limited in that way. It has its advantages, right? Interoperability is one. It's easy to develop stuff, but it's limiting and performance is terrible. And yeah, so the Tendermint has a different approach. So Tendermint, one of the core ideas of Tendermint was to separate those, and Tendermint and to have networking and consensus, which is Tendermint Core, and then have basically like an API interface, which is called ABCI, which is the Application Blockchain Interface. Yes. So that you can write your application on top that basically uses like an API to get data and write data from the consensus and the blockchain layer. So this way you have like a clean separation that if you write an application, you don't have to care really about the underlying stuff. And there's some other reasons also why you don't have to care about the underlying stuff. And yeah, you can kind of cleanly separate that. And yeah, so that's kind of how Tendermint is architected at this point. So you have applications on top, you have the networking consensus. The networking consensus is this, consensus, maybe you can speak a little bit more about. So the consensus, the Tendermint consensus was started in 2014, work on that, and it was inspired by the whole literature around Byzantine fault-tolerant algorithms. So there are academic papers on that starting in the 80s, and Tendermint basically, or Jay back then, he looked at the proof of work and some other efforts and said, okay, this is not very efficient. Can't we use some of this research that was originally done, adapt that for a blockchain environment, and then reach or basically build consensus engines like that? So Tendermint's been around now for, I guess, sort of 4 years soon, so quite a long time. And this is the fundamental idea of Tendermint. Now, Tendermint is very suitable for both public and private chains. Well, for private chains, it's been used for a while as well. At least in this whole POC environment that all these private projects are at this point. And for the public chains, well, this is what we're now working on with Cosmos. Now, Tendermint works basically like this. So you have different validators. The validators have different weights based on how many tokens they have. So let's say we can assume, let's say there's 10 validators. They all have 10% of the tokens. They all have basically equal weight in voting. Now, the block gets proposed, it gets passed around. People or the validators vote on that block, and as soon as more than 2/3 have basically voted yes, this block is fine, this looks good, it's committed and it's finalized. So this also means that every block is, we can lie on it. You know that this is the real block, there's not going to be another block. We don't have to wait for a bunch of confirmations to make sure that this doesn't get rolled back. It's also very scalable, so Tendermint can do, I think, something like maybe 10,000 transactions per second, and the block times are 1 to 3 seconds with, I think 100 validators across all continents, things like that. And it's also inspired a lot some other, work in proof of stake. In particular, Casper is based to some extent on Tendermint. But yeah, so a little bit more about this finality and forking thing. So of course, with Bitcoin, right, you have this idea that the longest chain is the most secure chain and thus is the kind of true chain. And this means that you can have multiple chains at the same height. And if you want to have security, it means you have to wait for some confirmations. So the problem with this is there's a bunch of problems. Of course, there's the huge energy inefficiency, which is one problem. But another problem is that if you write an application, then you have to kind of wait, or you have to be somewhat aware of the consensus and have to take that into account when you design your applications. With Bitcoin, that's comparatively simple because the applications are simple. It's basically sending money around, right? So where do you have this in reality, right? You have let's say an exchange or a payment processor says, okay, we have to wait 6 confirmations to talk to some nodes, see how many block deep it is, and then they say, okay, now we can update the state. But of course, if you talk about Ethereum, it gets much, much worse because you have many more blocks, so you have many more of these forks, and then the application state becomes much more complicated because if you say, okay, now we're gonna show some other thing on the interface and some prediction market thing takes place, rolling that back is a total nightmare. So this is also one of the core ideas of Tendermint, that this is unacceptable, and the idea that application developers are basically going to have to think through like forking logic and incorporate that in their user interface and rollbacks and all of that stuff is completely impractical. And that for that reason, blocks being final is really, really crucial. So that's also one of the key benefits of Tendermint. Yeah, so what can you do with Tendermint? Of course, because it's very flexible, you can build a lot of different things. And again, because you have this basically API, and afterwards you can write your application on top, well, one of the applications that you can put there is just the EVM, right? So basically, if you have this here, you have Tendermint Consensus or the Tendermint Core, and then you have the EVM running on top and using ABCI to speak with the consensus layer. And this is a project called Ethermint. So then if you have Ethereum application, you can just take that same application and put it on Ethermint, and it will run basically exactly the same way. Of course, the big difference being that the blocks are maybe every 1 to 2 or 3 seconds. It depends a little bit on how the network's set up instead of every 15 seconds. And in terms of scalability, it will be maybe 20 times as much throughput. And then there's the finality aspect as well. So this is kind of one thing you can do, but of course you can have other types of applications too. In particular, most of the Cosmos stuff is not written on the EVM and doesn't use that thing, but it uses another thing called Cosmos SDK, which is basically like a cryptocurrency framework written in Go. And then there's this concept of kind of plugins too, so that Cosmos SDK is kind of modular as well, and that you can have different kind of components that you can just sort of plug in there. Governance being one of them, but there are other ones too. So now we kind of get to the Cosmos ecosystem and what that looks like. So the Cosmos ecosystem is basically a whole set of blockchains that are all running Tendermint Core. Now they could be running something else too, but the key thing here is that blockchains in the Cosmos ecosystems kind of have to get to a point where there's finality, where they actually can say, okay, this block we can rely on. And those blockchains are then interconnected using something called IBC. So IBC is the Inter-Blockchain Communication Protocol. Now the nice thing about Tendermint 2 is that you can have very powerful light proofs. So light proofs, for some are probably aware, there's things like a Bitcoin light client, something like Electrum, right, that you can run on your computer, and it can verify the Bitcoin blockchain without having to run a full node. So it doesn't have to get like all the blocks and all the data, but you can still be like very, very certain that when you get this information, I've received the payment, it's actually accurate and it can't be fraudulent. So Bitcoin has these SPV clients. Now the nice thing in Tendermint is that you can do very, very efficient light client proofs. In particular, you can have one blockchain be a light client of the other blockchain. So they can both be light clients of each other, and they can thus verify transactions on the other chain. So what this makes possible is that one chain, that you can basically move tokens from one chain to another or move data from one chain to another. And there's this protocol called IBC which does that. But it's actually a pretty simple protocol. So So then you have this network of interconnected blockchains. In the middle, or the kind of first one we'll launch with is this thing called Cosmos Hub. And the idea of the Cosmos Hub is basically that for this to be most efficient, is the Cosmos Hub is going to be a light client and verify like all the other blockchains in the Cosmos ecosystem. And so it almost works a little bit like it can route tokens and data throughout the ecosystem. So if this chain wants to talk to this chain, it doesn't have to have a direct connection. You can just sort of route it through the Cosmos Hub. And that also prevents kind of double spending, right? Because the Cosmos Hub can kind of keep track. Okay, how many tokens have been created here, and how many have been moved in here, and then how many are in other zones. So it can all kind of be kept track of in the Cosmos Hub. And now the nice thing is you can have all kinds of different blockchains connected to that. So you can have something like Ethermint connected to that. So that means you could have a blockchain that is just like Ethereum, right, where you can have all kinds of Ethereum applications in. And let's say if people have today application that they're trying to deploy in Ethereum, but it doesn't run or it's too expensive, they could just take the same application and also deploy it here, so it runs on both chains. And maybe there's some way in the UI that people can choose which chain they want to run it on. And of course, there's no reason why there just has to be one of these Ethermint chains. There could be 5 or 10 all running in parallel, all connected to the Cosmos Hub. And if you have something like that, let's say you have 10 of these Ethermint zones connected to the Cosmos Hub, and each of those has like 200 transactions a second, well then you had 2,000 transactions a second, and Ethereum today has like 15, right? So we had like more than 100x improvement. So if you look at all the scalability issues that we have in Ethereum today, well, if this is launched and there's Ethermint zones and they work, they're kind of solved for the time being. Now what you can also have is you can have chains in this Cosmos ecosystem that are application specific, right? So let's say someone wants to do a prediction market. Well, prediction market is going to have like lots of transactions, right? But they're mostly like internal to that market, right? There are people putting on trades and those trades getting settled, et cetera, et cetera. And well, a project like that could create their own chain. And of course, that has a lot of benefits too, because then you can also get rid of the EVM potentially and build these kind of customized chains around what the use case and the requirements are. Yeah, and then there's other things. Well, in particular, one thing that's interesting is connecting to private chains, because you can have a private chain running there where you can't see the data, right? So it can be part of the Cosmos ecosystem, but still you cannot see the data in here. You only know, okay, we have these validators that are basically running that chain, and they can write data onto Tendermint Core. So for example, you could have like a consortium chain here that's issuing like energy credit or something like that, and they're then they underneath in this consortium are using this blockchain to make sure that the credits and the data, etc., is managed correctly, and then they can basically issue assets on the Cosmos Hub, and it can be tracked there. And so as a user, I will know that, okay, all this asset that's coming there, it has been signed by all these companies that are verifying this chain. You know that you can have transparency on the supply, etc., without being exposed, or without the kind of business logic and potentially privacy sensitive data on the private chain being exposed. So I think that's also interesting, and hopefully we'll see lots of that. Now, to connect with existing blockchains can be a little bit more difficult, because those often are proof of work based, like Ethereum or Bitcoin, and then you have the problem that there's no finality in the chain. So with IBC, you kind of rely on this concept of finality, so that you know this can't be undone, because if it can be undone, it gets like it becomes a mess, right? Because then you have like double spends in Cosmos, and it's a mess. So you don't want that. So one solution to this is having basically these kind of peg zones. So these peg zones would then be run by validators that are, validating the Ethereum chain at the same time as they are running the validators on this Tendermint chain. And so they can say, okay, if it's enough confirmations deep, we say it's like quasi-final. And then let's say, so Ethereum could be put into some smart contract here. You wait for enough confirmation that you're sure that, okay, this Ether is actually in that contract. It's not going to be like double spent. And then those signers could basically issue Ethereum tokens on the Cosmos Hub. And this Ethereum is frozen here. So you have like fully backed Ether on Cosmos. So it would be equivalent really with Ether. It should be exactly the same value. And you could then use it to pay for transaction fees or for anything you want. And then if somebody wants to take it back, they basically send that money back to the Cosmos Hub, that contract there, it gets destroyed, and then this will get released over here. So there's been a Cosmos hackathon going on for a while, and we had like this high school kid from Korea who won one of the hackathons by writing the IBC verification as an Ethereum smart contract. So he's like, pretty cool. Yeah, so what are the advantages of this? Well, one thing here, first of all, there's the aspect of diversity, right? So you can have lots of different blockchains with different characteristics, different features, different virtual machines written in different languages. They can all like coexist and work and function in Cosmos ecosystem. You can also have privacy, right? So you could have, I mean, potentially you can have privacy zones like a Zcash zone and things like that, but you can also have private chains and they're all connected and, you know, should work pretty well. And then of course scalability is one of the core features. I mean, this is kind of a boring way to scale, right? It's not as fancy as like Plasma or Lightning Network, or all these sharding, all these very complicated ways, but it's very feasible, right? It's clear how this works. All of the components basically are there, and there's maybe some final work that has to be done, but this isn't like years away like most of the other scalability efforts, or like the ones we see in Ethereum, for example. You also have security, right? Because well, first of all, you have a bonded proof of stake, right? So you have validators put up security deposits. They get slashed if they do something wrong. So from a game theoretic perspective, like this is much more secure than proof of work, or at least it should be. And then I think the last thing is also very important, like sovereignty. So when you have this here, like each of these chains could have its own validator set. And so you can have different communities that are managing their own chain. Now in particular, right, if you have an application chain, let's say Gnosis did a zone here, then they could have their own token holders basically putting up security deposits and validating that chain. And I think that's fantastic, right? Because it means that they all of a sudden gain control of the full platform. So if they need to make changes to the underlying architecture, they can do so. And you don't really have those conflict of interest anymore that, you know, are a huge problem for Ethereum, right? With Ethereum Classic and you know, if you think back to the DAO, then you had this big problem because you had all these DAO holders and they got their money lost, so they wanted to like reverse that. But then you had the other Ethereum holders who were like, well, this is not our problem. We don't want to roll back the chain. We were promised this was immutable and code is law, and now you guys want to change that. So you have a conflict of interest. And, well, it's understandable, right? Because you have different groups of stakeholders living on the same network. And now, well, their interests are going to collide, and they somehow have to battle this out. And it's kind of a mess. So the idea of having many different zones or blockchains that have their own sovereignty, their own communities, their own governance system, and they can all interoperate, I think is a very important one, and hopefully this is absolutely required. Yeah, so just briefly on scalability, I mean, we've kind of talked about this already, but you know, there's two ways, you can think of two ways of scaling. One is to say, this idea of like vertical scalability. You have one blockchain and you try to make that much more performant. So of course proof of stake is one thing. Proof of stake already is a big improvement over proof of work, and probably gives something like, I don't know, 50, 100x or something like that improvement. There's other things like state channels, fancy things like recursive snark, I don't understand. But of course the other thing is horizontal scalability, just like putting chains next to each other. Now, as we are seeing with proof of work, it does not work. You cannot do this. Like now we have in Bitcoin, right? We have in a way horizontal scalability. We have like Bitcoin and Bitcoin Cash and stuff like that. But what problems does it lead to? Right now, one of them gets more expensive. The miners switch to that, then the block times gets longer, and then they switch back there. It's a complete mess. So you can't. It's impossible to have horizontal scaling in proof of work chains. But you know, here in Cosmos, this is straightforward and easy. Yeah, and especially application-based kind of you can call it sharding, or basically applications having their own blockchains is very good. And that also means that if you care about a particular application, well, you just run the node for that chain where that application lives. But of course, in Ethereum today, you care about Golem or something. Well, you have to still, if you want to run a full node, verify all these other applications that you don't care about, you never use, and that makes it very expensive to run a full node as well. Let me see. Yeah, and here we can also have, so application-specific chains really means that you can kind of custom build the chain around the application. So some of them will look very, very different. I mean, the idea of a Turing-complete chain, it makes a lot of sense for experimentation, for POC, because you can quickly build something new and you don't have to make deep changes. But if it comes to the point where you actually want to like go into production and you're going to have a lot of users, then performance and scalability, as we are seeing today, becomes super important. And then these Turing-complete EVM chains don't make a lot of sense. But then it may make much more sense that you have 10 or 20 or however many kind of like Bitcoin, like opcodes for the features that chain needs. And then you could do that. And of course, with governance and having votes on that, you can then still update that chain. And of course, again, with Bitcoin, we have the problem that even though it's a pretty efficient system for what it can do, you don't have an upgrade process, right? So it's not flexible. But that's because there's no governance in Bitcoin. If there was governance in Bitcoin, I'm sure we wouldn't have had years of fighting, and there would have been upgrades much earlier. It also reduces the attack surface because, of course, having Turing-complete chains makes also for lots of vulnerabilities, as we have seen recently again with the parity multi-sig thing, and those kind of things are almost unavoidable with Ethereum chains. But if you have application-specific chains, you also don't really have that problem. And yeah, I mean, IBC really is, you can think of it as the original sidechains concept that was advanced by Blockstream years ago. Of course, the big difference is that the sidechains concept that Blockstream had was dependent or vetted to this proof of work concept. And that doesn't really make a lot of sense because the security of those sidechains would get very, very low unless you got all the miners to basically validate all the sidechains. But even then, because there's no security deposit, you can't punish them if they do something wrong. So the sidechains concept back then was really flawed. But with proof of stake and this easy way to verify that we have in Cosmos, the sidechain concept actually becomes super possible. And yeah, and this is not just, it's also a very different thing from a token swap, right? Often people have probably heard from atomic swaps. So the idea that, okay, let's say I can send some Bitcoin to you on the Bitcoin chain, and you send some Litecoin to me on the Litecoin chain, and we can make sure that both of those complete without having to trust a third party, and so we can basically trade, sort of. But this is not the same thing here, right? Here you can actually like move the token over. So you have an Ether. Before, you still have an Ether, except that Ether has been transferred basically to a Cosmos hub or a Cosmos zone. And yeah, I think sovereignty is just another example here why this is key. If you think of Ethereum and Ethereum Classic, I mean, if you move to a proof of stake world, like it doesn't make any sense that they would have the same validator set. They have different philosophies, different communities, different interests, so they should have different validator sets. So again, I think that just points to the necessity of having a kind of Internet of Blockchains world where you can have sovereign chains. So I think this is also a contrast to Polkadot, because people often ask about that. So in Polkadot, you basically have like this one overarching validator set and security base that's running many chains in parallel, which of course is very cool too, but it doesn't give the individual chains this sovereignty. Yeah, as you can see, Sunny is a fan of Lieberland. Yeah, so that is basically it. The basic Cosmos vision is that we can have a whole ecosystem of interacting blockchains that are highly efficient, where we can have tokens that are able to move between chains, so that you can hopefully in the future do something like use Bitcoins to pay for smart contract execution elsewhere. And I think decoupling Bitcoin from the Bitcoin network would actually also be a huge thing. Of course, with Bitcoin, it's hard to do this whole peg zone that is a very difficult thing to do because of the limitations of Bitcoin. But hopefully it will be possible at some point, and of course it will be amazing if we could actually move the Bitcoins away there and use in a more scalable way, and maybe that would also solve some of the problems in the Bitcoin universe and some of the disagreements there. Yeah, I think, well, there's this wonderful picture, as you can see here, lots of coins living happily next to each other, like in a beautiful rainbow, which is basically the idea of this whole thing. So yeah, if you have some questions, we can do that. Yeah.
They agree on each other, and how would they, where would the transfer logic and the business logic sit?
Sure. So the question is, if I understand it correctly, so if you want to do more than just moving tokens between chains, but you actually want to like call contracts and applications between chains. So this is not something we're working on because it's just much more complex, right? So I think it's important to get like this right first. In print, but afterwards, absolutely, I think is something that, you know, at some point we will try to do as well. Yeah, I think this is one of the reasons, right? So Cosmos is planning, you know, we're anticipating a launch soon, right, in a few months. And if you look at Polkadot, right, which is trying to do that, well, they're planning a launch in like
2019.
Yeah, 2019, right? So 2 years, right? So I think that is one of the key reasons, exactly, because it's this really, really hard thing. Now, that being said, if they figure it out, then there's no reason why it wouldn't work here as well. Or at some point, I think when this is working and this is working well, then this is also something that can be tackled. I think one thing that is possible, I mean, it's not the full contract calls across chains, but it's basically like that you kind of verify data across chains. So that, I think, is also fairly simple.
Yeah, but where would the logic be which verifies this? Is it an extra blockchain which is also connected to that hub?
No, the verification of the proofs happens like in the blockchain, right? So you basically have a proof, right? So let's say you move some data in there, in this IBC, there's like an outbox, kind of, like an email outbox or something, and then you have a proof, okay, it's in there, it has been signed by all the validators of that chain, and then I can basically put this proof over here. Now, here, you know that we have a proof that was signed by the validators here. We also, the hub also keeps track of the validator sets of these different chains. So the hub knows, okay, this is the current validator set that has signed this. And so then you know that this data is coming from there and it is authentic and it has been signed by them. It's not the full like calling applications across chains. Like that will not be possible with Cosmos in the foreseeable future.
Do you think this is on the schedule?
Yeah, at some point, sure. But to be honest, I'm not. I don't understand how. I haven't spent time thinking about how contract calls will work across chains. So I'm not a developer either. So I'm not the right person to ask about this.
Is your strategy to like build this network of final chains, build up Tendermint, or to connect to existing chains? What's the main focus between the two?
I mean both. I would say the first focus is to launch the Cosmos Hub, and then I think there will be some chains that are, also new chains. In particular, the Ethermint chain is the most important one, where you have like a chain where you can run Ethereum applications. And then I think the peg to the Ethereum network as well is kind of a high priority, and that's going to happen pretty soon. Other things like pegging the Bitcoin, I think that's much harder, and that is not something we're working on at this point. I mean, if somebody like Rootstock or others, I mean, I think there are a bunch of projects that are trying to do this, and if they figure it out, we could also just copy that. But yeah, I think initially the hub, Ethermint. There are a few projects that are kind of working on developing their own zones, their own Cosmos zones as well. We've also had conversations with there are some projects thinking about kind of developing their own application-specific zones. So hopefully that's also something we'll see pretty soon.
So if I want to start writing an app using that APCI interface tomorrow, where can I start? Where can I find documentation on that topic?
Yeah. So the question is, how can you start writing ABCI apps? So just Google Tendermint ABCI, and there's like documentation, and there's also the Cosmos SDK, which is being used for the Cosmos hub. So it's this cryptocurrency framework in Go. Yeah, so you can start using that, and yeah. Cool. Let's do. If somebody has more question, do one more. All right, cool. Then thanks so much. Here's your.
Okay, this is you are recording this, yeah?
Yeah, this is a live stream.
No, that's sure. So what should I do? I should take it this like that.
Yeah, and this here on your.
Oh, I can do it like this, yeah?
Yeah.
Okay, perfect. And then what? Sorry, in here.
Here.
Okay. So I'm not used to this. Okay.
Yeah, I think this looks fine.
Okay. Yeah.
Should we take a short break? I don't know.
I don't know.
Okay.
I think it's getting late, and you can take a 5 minutes break.
Yeah. Let's take a 3-minute break, and then we get. So if you want to drink, and then let's get started with.
Neufund. Yeah. Okay. In 3 minutes, guys.
There's a mute on your microphone right here.
All right. So hello, everyone. I'm Marcin Rudolf. I'm co-founder and system designer of Neufund, which is a community-owned fundraising platform. Yes, and thanks for staying so long. I'm going to do it like in very quick way, I hope, and yeah, I hope it's gonna be very interesting. All right, so basically, Neufund is a community-owned fundraising platform. This is pretty extensive projects, and we had a lot of nice introductions to blockchain today. I'm gonna do another one. From my perspective, I think Trent has a background in artificial intelligence, so he sees a blockchain and uses a metaphor of like a training some kind of evolutionary algorithms that behaves in the similar way. There is like an optimum that it seeks and so on. So my background is in computer science, but also sociology and system theory. So I'm gonna use this metaphor, and I think it's gonna be interesting because we had a pretty extensive token system in this platform, and it was designed with the people in mind, like a people interactions and behavior. So yeah, so let's start with what is blockchain from my point of view, and a few other things that are like necessary to understand what I'm gonna talk about later. So basically, blockchain lets people to interact or make very complicated transactions without trusting each other. Yes, so I know. Let's take a look at internet, how it happened and how it changed society. So basically, internet is a way for people to communicate in the peer-to-peer fashion without intermediaries. Yes, and this is not only the technology. Yes, we know the TCP stack and the HTTP stack and so on, but this is also a kind of revolution and impact it has on the society because it changed how people communicate. When you change how people communicate, you change everything because basically society is a communication system. So this is a huge impact. It was just a start. Yes. Now we have a blockchain, and blockchain allows people to do more complicated things than just talk. Yes, it allows people to make very complicated transactions without intermediaries. Yes, so this is like a starting point in our system design. The next thing that people perceive as a technology, but basically this is something more. Yes, there are smart contracts. Smart contracts are interfaces for people to interact. They define some rules, they define some actors, they define some incentives. And then the system design basically is to align the incentives of the people that's going to use it. Yes, this is not about writing code. It is, of course, very important to write good code, yes, afterwards. But it's also important to design the system in a way that people are doing what they're supposed to do. Yes, I think the Trent talk about that as well. Yeah, so this is very similar, I think, approach. Then we have tokens that are basically a type of a smart contract. It's designed to represent some value, and it's designed to let people own something on blockchain. Yes, so this is like the three definitions that I'm gonna use. Okay. Okay, so what is Neufund? Like a Neufund is a community-owned fundraising platform. So it basically lets investors of any kind to found new projects, which are, in our case are off-chain companies, yes, for which we are designing a new type of token to found this off-chain businesses that are sometimes not a blockchain type of businesses that is represented as a network, but I don't know, a shoes factory or a car factory can also use the ICO process to fund its operation. Yes, so basically Neufund is a kind of legal, technological, and system structure that allows to do it, allows to found any kind of business in the world with any kind of money, not only the crypto money, but also it's a gateway for the classical investors, VCs that want to convert to blockchain. And I'm like leave this existing kind of framework when there is a lot of gatekeeping, a lot of very fragmented into something that is like organized as a really network of investors that can fund innovation. Yes, so blockchain, so Neufund has many different aspects. It's a product for the end user. It is also very complicated and elaborate legal framework that let token holders to hold real shares in the companies with all the shareholder rights and so on. But it is also a blockchain design system with the tokens that should align people to simply get together and fund innovation, fund new projects. Yes, so I'm going to talk about the tokens that we've got, and the first token I'm going to talk about it's called Neu token. It's a token that basically represents the value of this platform. And okay, so I need to start with some basic introduction to what, in my opinion, is I don't know, what is the very fundamental principle of blockchain economy? Yes, and you have it in the Bitcoin. Yes? We always start with the Bitcoin, which is really something that's revolutionized this kind of thing. Put it really all these questions about the work, the value, and the ownership back into the rethinking mode. Yes, so basically, this principle is that whoever works for the network should own this network, yes? And then in Bitcoin, it's a pure example of this. So every Bitcoin was mined, yes? Every Bitcoin was created for providing useful work for this network. In that case, it's electricity, but this is like creating this consensus via a proof of work. So everything was created this way. Every Bitcoin was mined, yes? It was a reward for creating this network, yes. So we have the same principle in Neufund, yes. So we need to reward people that work for us, for the platform, for this ecosystem that increase its value. And in our case, the investment is this kind of work, yes. So according to this principle, people that invest should own this network, should own this ecosystem, should be rewarded with the ownership. And this is exactly what the Neu token is doing, yes. So Neu token is not a kind of gatekeeper to investment, it is rather a kind of incentive, yes. So whenever there is an investment transaction, so someone funds a project, yes, someone puts some money into some kind of cool project, creates an innovation, as we say, our resource is innovation, I mean, yeah. So our resource that we create is innovation. Whenever this happens, this investor is rewarded with our token. Yes, this is like something that we grant on top of the actual investment. And this token, so this token it's not bought, it's not created, yes, out of the air. It is issued only when some useful work is done. And so this token has a very specific value. This value is a share of the let's say, economic output of this ecosystem. So whenever there is a successful fundraising completed, it is a small part of this amount, a fee, is shared back to all the token holders of this platform. So this is one component. The second component is like a little bit also of the token of this project is also shared back. Yes. So this way, every investor that ever does investment on our platform or on the platform is also aligned with every company that was ever ICO'd in there, yes, so owns a little bit of share of everyone. This is like we call it a platform portfolio. So this very strongly aligns investors with the companies and also aligns investors together. All right. There is another Bitcoin concept, yes, that's our tokens are easy mined at the beginning of when the network is really young, yes, because at that point we need to really kickstart it and make it going. So this reward is much higher than later, yes. So this reward rewards the risk takers, rewards the early adopters, and makes people coming to this platform. All right. So there is another very interesting consequence of this kind of thing that's by the system design, we couldn't do the real ICO of our platform, yes? We did something different. It's called ICBM, and it stands for Initial Capital Building Mechanism, which you also could call Initial Community Building Mechanism, yes? Because this is an initial Neumark generating mechanism, yes, in which we do not sell any tokens, yes. In this mechanism, people come and say, this platform has potential. I'm gonna commit a little bit of money or reserve a little bit of money for the future investment. Yes, it happens in the escrow smart contract simply. I'm going to reserve a little bit of money, and for that already we are rewarding this person with Neumark. Yes, this creates a kind of decentralized capital pool. People that already are committed to invest in the future, in the coming deals to the platform. And I mean, like solving a kind of chicken and egg problem when you don't have any capital and any deals. So this is building this capital side of the platform. Yes, and investors get the Neumarks, we call it Neumarks or Neu, yes, already in this process. Yes, so this also has an interesting mechanism that we, as a platform operator, we do not get any money from this. Yes, we do not get any money. All the money goes to the funding of the project in the future by individual investors' decisions. And what we get is a share of a NOI that is created during this process. Yes, so this is, I call it this vesting without vesting, because we get this only when there's successful transaction on the platform. Yes, so we do not pre-allocate anything, we do not take anything before it really happens and it's really earned. The work is, I would say, done. Okay, so that was the NOI token. Okay, the other thing that is very important, it is we call it equity token. Yes, and this is a very interesting topic from the legal perspective, but I will not be doing this. I can take any question about that, but I'm gonna talk about something else. This is basically the whole thinking about how you can really invest with tokens. Yes, because I mean, like the current situation, it is not so obvious how to do it with the existing token types, which we call utility tokens. Yes, so this tokens represents a kind of service or a voucher for some goods, and basically they are. Every blockchain or every proper blockchain project is a small economy. Yes, it has some resource that is created. This resource should be created in some optimal way. I mean, the network should be in balance. Yes, or in equilibrium. This equilibrium is expressed via token price. If you have a good token price, there is maximum number of amount of this goods is created. Yes, so this is like a small economy. And now you have the token that represents the value of this economy. It's called the utility token and represents directly the goods that are created in there. Yes. So yeah. So the problem is that this organic growth. Do I have it? Yes. Okay. This is here. So this organic growth of this kind of economy without any bootstrapping and without any capital that is coming in from outside, any value from outside, it's going slow. Yes. It's a network effect. Starts smaller. It took a lot of time for Bitcoin to start increasing in value massively. Yes, because that was this very long time when there was not many miners, the network was not simply funded, and so on. Yes, so people that create these tokens, yes, right now the app tokens, they are trying to solve this problem, overcome this problem, and there are two ways to do it. One is doing this primary financing, which is called ICO. So basically you create your tokens in advance and you sell them, but they still represent a kind of good. I don't know, like you are selling a future computing power, yes, on a massive scale, for example. That's the one thing. The second thing, you are establishing a secondary market. Yes, and then you can trade this token and it can increase in value due to speculation of people betting on it and so on. So this secondary market basically drives the price of the Bitcoin now, yes? And the primary market is used by any kind of blockchain projects to obtain the initial funding. So there are two mechanisms that are used to put external value into app tokens. Okay, so this way the app token is losing its role of being a pure indicator of the network value, of the value of the resource that is produced inside. It's getting another role. This another role is an investment function. And this has some interesting consequences. And yeah, so to me, it was like I was spending some time on this. What does it mean to invest in app token? So to me, this like a metaphor is do you invest in Tesla, buying a lot of cars from the Tesla factory, yes, and then selling this on the secondary market. So this is not how to do it, yes? You basically buy a share of Tesla business instead of buying a lot of cars. or voter forecast. Doesn't matter much. Yes. The other thing, I mean, like with an impact that it has on the resource. Yes, we are deploying some smart contracts a year ago. Well, a little bit less than a year ago, yes, and we paid, like, I don't know, there was like one of these peaks, like $200 per smart contract system. A few months earlier, I would pay $1 for that, yes, because the Ether was for $6, I think, per one. It was like I think this was December last year. And then the question is, did the price of computing power increase dramatically over these 3 months? No, it didn't, yes. So what happened? What happened? Why, as a consumer, as a user of this resource, I had to pay so much? And by the way, Ethereum has this gas price mechanism that is probably, I think it's by design, a way to decouple this price of Ethereum, which probably people that create Ethereum already predicted that it's going to be a problem with the Ethereum value. They try to decouple with the gas price. But it doesn't work, because this market can't really stand so many changes coming from the speculators. So today I think we have a pump of 30%, and why should I pay 30% more for computing power? It's not explained by the resource itself. Yeah? Questions, yes?
Your contract became 100 times more secure. The security is 100 times greater.
I mean, like if Ethereum is just a simple network as a Bitcoin, then yes, but Ethereum is a computing power, like a consensus computing power, yes, and my contracts are not much secure because there's a Turing machine in there, and most of the insecurity comes from that. Yes, of course, maybe we are talking about the billions of dollars, but our ISO plan is just for our employees, yes? So, I mean, like we are not billion-dollar business yet, so, yeah. So, probably doesn't explain the increase. To me, as a consumer, yes, I'm talking about as a consumer in here. Okay, so we started to analyze this. Yes, why this is like that. Yes, and basically, if some external people come and put this network out of the equilibrium, this alignment between the people that produce this and then consume this resource, it simply goes away. Yes, because what this consumer and a miner want, they want to maximize the output of the network. So as many goods are produced as possible. This is the optimum state. Yes? So as much computing power as possible as can be consumed and so on. But investor has a little bit different, or speculator has a little bit different approach. Yes? They want to pump this up or pump it down or dump it, the price according to some short-term speculative, I don't know, gains that they can take it. Yes. So we destroy equilibrium this way. So network is not in optimum, let's say, state. It doesn't produce as much good as it should. Okay, so there is another thing. Yes, this is what I heard many times. Why should I ever sell and use my bitcoins? They are so valuable, so I just better keep it and don't use it. Yes, and now there is a problem. Is Bitcoin has any kind? I know that the Bitcoin right now is more like a gold, or you don't really touch it. It goes basically useless in some way. It's just a store of value. But let's say you have another type of network that has some other usage. Let's say a file storage or something like that, and you have a lot of investors, they pump the price up of the token, and then people stop using this. Because the price is too high. If you have this token, you will not sell it because you think this is a good value, and the consumer will not use it. So this is very well-known, I think, well-known mechanism for, I don't know, hundreds of years, yes, that you have two alternatives, yes. One is gold and one is a cheap thing, yes, but works as alternative substitute or functional substitute. This cheap thing is gonna win, yes, and this better money, this gold money, I mean, like this shitcoin will remove the gold coin basically at the end, yes, and this is like a kind of law that was discovered, I don't know, by Copernicus, by the way. That's very interesting. Okay, there is another issue that you can't really do a secondary round with your app token. The app token, if it really represents a value and you have established price, and you generate 30% more of these tokens and you sell it, then you can really destroy business of the miners. Yes, they will just take the rigs and go somewhere else. Okay, so I mean, we went in I think the simplest possible solution, looking at how humanity is dealing with this problem off-chain. Yeah? So there is this very interesting invention of equity. Yes, equity is a sharing business, can represent any kind of business model. I mean, maybe this has a bad opinion right now because there are really a lot of corporations that are greedy and so on. But the concept itself, a kind of abstraction of any kind of business model, when someone that has equity has some stake in the output of the business, in some stake in governance, information that is there, but it's not impacting how this business works. This is good and this is very interesting. So right now, Neufund is focusing on doing this like this bridge between the equity off-chain and tokens on-chain. Yes, but this could be only a start to solve this problem, because you can also represent this kind of share of business, yes, a share in the network via another token. Yes, that doesn't represent a value of the resource. It just represents the economic output. Yes, so when you have this token, you want to optimize the output of the network, like a miner or a user, because if this is producing more, you get more economic value out of this. Yes, so you don't really want to influence the price of this just for speculation. So yeah, so that's it. By the way, we have this ICBM open. It's already going. We have pretty nice network of investors off-chain and on-chain. So yeah, you can check it. And that's it. Yeah. So yeah, that's all. Thanks. Okay, this is Nathan. So yeah.
Fundraising platform in January, right?
Yeah, this is gonna be end of Q1 right now. Yeah.
Okay. And do you have already concrete projects?
Yeah, we have. I can't list them, but they are pretty interesting projects from many different angles. Some of them are, I don't know, some of them deal with hardware. There are a few later stage projects, gaming companies. There are some creative agencies that are interested and so on. Yes, so we have pretty interesting deal coming in. We also have pretty interesting investors, which also bring some deal flow. We have people from Early Bird invested. We have people from Sandstone, from Mangrove, from Atlantic Labs. We also have interesting people from the crypto space. I think also Brian is supporting us and other people. So I mean, this is more community building mechanism for us than capital building, because the size of this ICO doesn't really matter. We're already very happy with what happened. Basically, we need to convince every single investor almost separately, which I thanks to my team for doing that, because this concept is pretty complicated. Yes, if we don't do the ICO, we do some kind of fund commitment, we generate tokens as a reward, we don't take these funds. People at start do not understand this, so we need to really work with everyone separately.
Did I get this right, that each investor invests in every project which is the platform?
Okay, so this is how this token works. Yes. So when you invest in a single project, yes, you are like a miner to us. You provide a useful work to create a value, yes, because you invest in innovation. For that, you are getting a reward, which is a token that's generated just for you at the moment of this transaction, and this token, the value of this token is in the fees, yes, but also there is something, a construct that you can think this is a kind of index fund or something like this that holds a little bit of tokens of every project that ever was funded on the platform, and you have a stake in this.
Okay, and how is Neufund then being protected from, let's say, project spam?
I mean, okay, so there are, there are a few layers of this. Yes. So first of all, Neufund is providing this legal bridge. So we are, as a platform, are checking this basic legal. We are doing this basic legal due diligence. So the company exists, the team exists. You really know who is it. There is KYC being done on the founders and so on. So you know that at least this is a legit business that is somewhere incorporated and so on. Yes. But we do not judge the merits of the project itself. Yes, if it's a good business or bad. This we do it at start. Yes, together with our investors and so on, to provide a good deal flow that is already curated. But later, you do not want to do it. You just wanna provide incentives for experts or some SEO facilitators. Yes, to earn money when they're. I think this is always a similar concept. Yes, we're gonna let them stake on a project. Yes, and then if the SEO was successful, this ETO or this fundraising, they're gonna get a little bit of share of this money that was being simply from the funding. Yes, so there is this incentive. Also, the ICO process itself is a kind of vesting mechanism. Yes, for the project, because then people vote with their money. If the terms are not met, then the money is going back to the investors. So there are many layers that are checking if this project is really legit and a good business, good opportunity. Yeah.
The quantity of the new generated NOI tokens will be fixed or will be increasing over time?
This is a very interesting question, and we went for the fixed cap. Yes, so there is a kind of limit to how many Neumarks are generated. Okay, I have the reverse curve here with the decreasing curve. Okay, but there is a cap, and we believe that that at some point this early incentivization scheme is not necessary. So the Neumarks will be generated with very high difficulty, so almost no Neumarks per invested Ether, and yeah, then you can get Neumarks on the secondary market. Yes, if you like the platform. So there is a cap, yes.
And it's running on Ethereum.
This is a smart contract system and the app on Ethereum. Yes, and yeah, that's right.
So, yeah, but at what level is the cap set?
Yeah, the cap is set for 1.5 billion of NOI, which is more or less 1.5 billion of euro. Yes, I think that at that point you are getting like a less than 1 Neumark per less than 1 Neumark per 100 of euro. So
and the 1.5 billion euro is not the money you're going to invest in the projects.
No, this is exactly the money that is gonna be in. Okay, yeah. Please continue. Okay, so this is exactly the amount of money that's gonna be invested in the project, because the noise is generated only when there's investment. There's only one. This is not even a kind of exception, but we generate this Neumarks on the commitment now. Yes, but they need to be spent. Yes, if you do not spend them, you can take your money back if you don't like the platform, but you need to return this Neumark from this. You need to return this Neumark if you receive the Neumark during the commitment process. Yes, so before you invest it.
So let's say I want to invest like I don't know, 50 Ether or something like
that.
Then after a year or so, I say I want to withdraw like 20 or so. I need money to pay my rent, and I want to have some money back for 5 years or so. How does that work?
How does it work? So you need to, this is a smart contract. Okay, so I don't know, from the user perspective or system perspective, you need to, so you need to or still have or acquire Neumarks that you've got for free, yes, in this commitment, and send them back to the smart contract, and then Ether is gonna go back to your wallet. Yes, and you can take it. There is nothing more. And of course, if you if you decide to invest on one of the projects, this doesn't apply anymore. Spend money, simply freeze your NOI forever. Yes, you do not return anything and so on. So this is one of the incentives for spending this money on the fundraising.
But I don't want to spend my money forever. I mean, usually when you invest, at some point you want to get back something.
Okay, So in case, this is one of the things why you are doing this on blockchain, yes, because you can invest this money in a kind of token, yes, that gives you a shareholder rights, but this token can be liquid, yes, very quickly. This is not a VC world when you stay 7 years with your portfolio and wait for the exit. You can do it here as well. This is your choice, but you can also sell, yes? And this is very powerful mechanism because as we see, I don't know, I'm gonna take this example. Yeah, as you can see, I mean, speculators are sometimes good for the business, yes, because they come, they think they're gonna make a lot of money, they put a lot of money into a project, and they can withdraw, some of them lose, some of them win, but they are driving this money into different businesses, yes. Sometimes this has a not very good effect, like funding something that is stupid, but sometimes you fund some cool things this way. So this liquidity is not bad, yes, maybe for the seed, it's not a good idea to be liquid, but for some A round or even later stage, people dream about that often, or have a gray market for their shares. Like most of the bigger companies that are private have gray market. Okay? Yeah, Trent, come on.
I've always been a fan of this project, so it's very cool. Thanks for the explanation. My main question is, overall, this is for people who would have normally done a regular startup company, right? And where they're not trying to create some sort of tokenized ecosystem, they just want something that's more like shares, that's more
yeah, yes.
And that's cool. So which jurisdictions are you aiming for? Is it for like German companies, or is it for American? Or?
So basically, Neufund is German GmbH, yes. So the offerings of the tokens will be according to the regulated by the German law, yes, but anyone can do it in the world. I mean, you just need a proper legal system in a given country, yes, that is more or less stable and has a corporate, yes, structure in there, so you can have shares that you can sell. But basically, you can do it, and this is like on DAX. There are like companies from outside of Germany. This is not a different problem.
So one quick follow-up is simply, this is actually cool because I know, like, we're chain to be as a German GmbH, of course. Every time you take in one new investor, all the existing investors have to, well, you and I were talking, they all have to sign, right? And so this actually really reduces friction. If it's basically you have a previous sort of company startup model, but now it's just way lower friction for sort of dealing with a lot of the legals. And I guess that's maybe one of the main value propositions of Neufund. Is that you basically have a more lightweight approach to handling some of the legals.
Yeah, so tokens are much more flexible. Yes, when you tokenize part of equity, there is more freedom, yes, for you as a funder, yes, and for the early investor as well, yes. So of course, having a part of your company public, this also means that you gonna have some kind of market valuation for this part. So this is really, I don't know, dilemma that you need to solve, yes, for your company if you wanna do it or not. But you don't need to trade, yes. You can tokenize and do the peer-to-peer transfers, no official trading and so on. Yeah, there is a question from.
If I invest in at least one project, so in future I get rewarded a little bit from every project.
Yes.
What you said.
Yeah.
So how is the relationship? How much do I have to invest in one project, and how much do I get out of the other? Where's the link between?
Okay, so you are asking about the numbers, exact numbers.
I invest 50 Ether, like you said. Into one project, and there are 10 projects, so how much do I get out as a reward from all the other projects? What's the relationship between these amount of money?
Okay, so I would need to do some computations, yes, because you have you have a 50 Ether, so in 50 Ether, I think Ether right now is 900 NOI, more or less, so multiply by this, and yeah, this is a small share of the platform, yes, because probably gonna to have a significant, I don't know, returns from Ether, you need to invest a little bit more, yes, but.
You say in percent, how many percent maybe do we get out of this?
From 50 Ethers? Yeah. So how much is €1.5 billion in Ether? Yeah.
No, but
I mean, the noise incentivization scheme, yes, and you shouldn't look at noise as the only driving factor for this platform. You first of all invest in a project that you support, yes. You should have returns from this. Then you can trade this noise if you don't like it for some reason, yes. So the fees are for hodlers, yes. If they like this platform, they will keep this and they will be rewarded for that. Yes, we want people to be aligned. They want people to stay, to invest, and so on. Also, someone that has this NOI, it's in the interest of this person to increase the number of investment, not directly, but maybe by organizing deals or working as an expert or working as some kind of syndicate organizers. I don't know. This, yeah.
I think maybe just to clarify the last question, I think when you invest, you're not investing in specific projects, right? You're just investing in the whole NOI fund.
You can't do it. You can't do it. You need to invest in specific projects to get this reward in form of Neumark, which aligns you with the rest of the ecosystem. Yes.
Okay,
so this is a reward on top.
Your money goes to a specific company, but then what you get back represents the whole thing.
Yes, okay. But also you get, of course, the share of this company in form of equity token. Yes. So yes.
Of that specific company.
Okay. So I'm gonna explain this like a different way. Okay.
You put in 10,000 euros, right? You get like 10,000 euros worth of shares, and you get some Neumark, right?
Oh, so you get actual shares.
Yeah, you get actual shares.
Like legally.
Yeah, I mean, like you get with current, let's say, status of the legal system in the world. Yes, you are getting something that is as close as possible to shares with all the rights of a shareholder, but this is still a token. So you are represented externally. This is all in our white paper. You are with a kind of transparent proxy, legal proxy, which is a kind of law firm that is doing everything you want with the company, yes, voting for you and so on. This is, yeah.
I mean, today I think we had actually a BaFin announcement that in Germany tokens are considered as units of account,
true.
not as securities. So what does that mean? That means if you buy a token, you have no right, no right.
No.
In the
So this is of course not true.
In the company, if I may continue.
Of course.
As if I would have when I buy a share. If I go to DAX and I buy an Apple share, I have a voting right there. If I buy a token.
You also have a voting right.
According to BaFin regulation and announcement, you don't have.
So first of all, BaFin said that this, I mean, what is a unit of account? It's a number of someone on someone's, okay, this is the basic denominator of all the kind of accounting things like money, shares, and so on. So they said that the token is like a balance on someone's account, nothing else. And they also said that in the particular cases, they're gonna to look into the function of the token, and they say what is it, yes? So we are pretty sure, because we are like in contact, working basically with the BaFin for a year now, that these tokens we consider security, and we are totally ready for it. Yes, so they will be.
You have to set up a prospectus, and just like
yeah, I mean, like depending on the ticket sizes and then how big is the investment. Then yes, there are different kinds of prospectus or different requirements. Yes, for some bigger deals with big tickets, you don't need a prospectus. 200,000 euro, I think, ticket. Yes.
Okay, so wait, if you could finish the answer to my question. So I invest in one company, I get kind of virtual shares.
You get the
actual company, plus I get tokens.
Yes, okay. You get tokens because you were a good player. Yes, you increase the value of this ecosystem, like a miner in Bitcoin. Yeah.
So it's like extra incentivization on top.
Yeah,
of,
and then
being able to invest in companies just through Neufund.
I mean, what do you mean?
You were saying that I can invest in a company through Neufund.
I mean, this is not a good metaphor, because you invest, you have Ether or Euro or Bitcoin, anything else. Nothing prohibits. This is a contract that you can put money in. You need to do the KYC. Yeah, that's true on Neufund. Yes, but this is not like you invest through Neufund, because this is an API that is exposed by smart contract. You can create my Ether wallet and do the transaction if you want. Yes, you don't need to use any kind of UI for that. Yes, but you need to proof of KYC to be stored on chain, and right now the regulations are that we need to do it. We would like to trust someone and just leave it this problem, but right now we need to do it. So you need to come at least to do the KYC for your Ether account. Yes.
Okay, great. And then you pick the companies that people are allowed.
Yeah,
to invest.
this money is still yours. True.
But you pick the companies that I'm allowed to invest in, right?
Okay, so the companies needs to come, do the basic due diligence, like the legal stuff I talk about. Like we need to know what the company exists, the team exists, the KYC is done for the organization, for the people. But then I don't like this phrase, but market decides, yes, what happened, yes? If the deal is gonna have any impact and the traction in the community, probably it's gonna go somewhere and people gonna invest. If not, the ICO gonna go down, yes, and the people gonna get a refund. Okay.
I don't know whether I got it right, but as far as I understand it, if I have a startup, doesn't matter whether it's a blockchain startup or any other, and I want to raise money,
Yeah.
I can come to you, Neufund, and say, okay, I want to tokenize my company, yeah? And through Neufund, I want to raise money through the investors in Neufund, yeah? That's the idea.
Yeah, but our investors are basically can be anyone that has Ether or Euro. Yes, so I mean I'm saying that this is not some kind of closed club of investors. Yes, this is very open structure. Okay, that's cool.
Anybody can invest in Neufund, so it's a crowdfunding mechanism basically. You're asking how to invest. But I, as a company, if I'm a founder, I want to raise money. I go to your platform, you check me, you check my team, you check that I have a legal business and so on and so forth, yeah. And then I can go on the platform and you don't do any further due diligence, so to speak, and say, okay, like a normal VC, they will actually do a due diligence and say, okay, we take those 5 or 10 companies in our portfolio, and that's where we put the money of our investors. You don't do that. Yeah, you say, okay, the market decides who of the retail investors will basically give me with my company money. Yeah.
Right.
Yeah, if you, I think your chances are much greater if you or bring some investors to the platform or know someone there. This is there are no magic money, yes, that's gonna just come to you. Yes, you need to campaign. You need to present some kind of proof that there is an interest, yes? Okay. So the best way to do it is to find some kind of syndicate that's going to do it for you.
Okay.
The first step.
As an investor, if today I want to invest in the startup field, yeah? And if I have enough money, I go directly to a VC and say, okay, here's €1 million, invest it for me, yeah? And I trust you that you guys do the due diligence on the 5 companies you're going to invest it in. And in 10 years' time, I come back and I want to have an average return of 20-something% per year. Yeah?
I mean, the mechanism today, yeah, this is exactly the mechanism. Yeah. But on Neufund or?
What's your mechanism here? If I'm an investor, if I have a
so this is like an investment, it's like a marketplace, right? Like there's like Ox Money or like lending marketplaces or equity marketplaces. Yeah. This is just the infrastructure, right? Like afterwards the projects, like investors choose them. It's not their job, right, to say what return.
I mean,
so I decide with my money. But I don't have the choice, or do I have the choice to decide, like you have like 100 companies on there, on the Neufund platform, and I can choose, I want to invest in company number 10 and number 15.
Yeah, then you choose.
Yes.
This is exactly like a stock market is working. I don't know, I didn't want to use this metaphor, but the stock market is also a pool of network of investors, and it is, of course, forcing the companies that are doing any business of the market to a little bit to conform to many different things. Yeah.
I actually have a way to help explain to you. Yeah? So given that you're already an investor, right? So a company comes to you and they're like, hey, invest in us, right? And you decide to invest in them anyway. Well, if you want some magic internet money on top of that, called Neu tokens, then you take that startup you say, hey, go on Neufund because I'm going to invest in you, and then I get Neu tokens, right? Is Neu coin?
Yeah, Neumark. But
so actually, Neumark, sorry. So overall, then basically VCs and seed investors, angels, all this, they're actually incentivized to basically keep acting like they already are for investing, doing their regular process, but getting all those companies onto here, right? Okay. So that's maybe
the way you are going to make money is basically because you get 50% of the Neumark generators.
Yeah, so whenever there's an investment, you get one Neumark goes to investor, one Neumark goes to us. But keep in mind, we do not take any money from ICBM. So this is the only thing that is like this is our revenue stream. No, but
I want to understand
yeah.
how
But
this works. And initially, the Neumark, basically, the value is more or less zero because I can't trade it today. Yeah.
no, right now there is just a primary market for Neumarks in the commitment. The secondary market, I think it's gonna organically grow simply. Yes. So.
Gonna list it on some exchange on what?
It rather maybe someone's gonna list it.
Huh?
I mean, like the listing on exchanges is a totally different thing, yes. And the value of Neumark shouldn't come from secondary trading. At least to me, as a system designer, it should come from the fees. It should come from the. But with a Golem token. Okay. Yeah, we are in the business model of this. So maybe let me return to this. Where is this? Oh, okay, it doesn't work anymore. Okay.
That's the interesting part.
Okay, so what is the business model of the platform? Yes, because we are just one of the token holders. So we have exactly the same alignment as other token holders. Yes, so we want to make as many investments in good projects as is possible. Yes, because then we optimize our. So this works like that. Whenever this ETO finished, yes, a small percent of this money that was in the escrow of the smart contract should go to the company. A small percent goes back to all the token holders. Yes, that's what company is paying, and a little bit of equity of this company in form of tokens goes to a special structure inside the platform, which I don't want to use this name, but it's the most similar to the index fund that is automatically optimized. Right now it's not optimized, just keeps everything in there and stays there. And you have a economic right to this structure. Like if there is any exit proceeds, dividends, you get a payout as a Neumark holder from this. Yes, you have two components. One is equity, one is cash. And basically, if you have Neumarks, you have rights to all the future payouts and to this structure of equity tokens. Okay.
In my opinion, you need a buffing license. Do you have one, or are you sure that?
For the buffing, yeah. If you want to organize trading, secondary trading, there is a buffing license required. But we are not in the trading business. Yes. For the issuance of if you issue this kind of token, you in some cases need a prospectus. Yes, and that you need to fill with buffing and have a statement from them that the prospectus is okay and you can proceed. That's true.
Okay, but that means for big investments, for every big investment where you need prospects, you need a buffing agreement.
Yeah, so this is actually pretty complicated because there is this crowdfunding regulations that I think are under 5 million or something. Yeah, there is very simple kind of prospectus, yes. Then you have under 200,000 ticket, there is no rules. Yes? It's like an accredited investor in US probably. When you take everything, there is a prospectus requirements, yes. But actually prospectus can be generated almost automatically if you have a proper pitch and budget and a few other things. Yeah, what's so funny?
Well, it's, I would guess some people are going to lose big money. Huh?
Yeah, of course. I would rather say they're going to make some money.
Do you know that VC investment is a game for rich boys, yeah, because it's you don't make money on it overall.
Yeah, I think the long-term return of any business, like 100 years, is below zero. That's true. Because we are getting to so generic level that it is true.
I recommend to you to read the Kaufman Foundation report on VC investment, and they analyze the real data.
Yeah, of course.
100 billion, and this is below.
Yeah, that is true, and I'm just saying that it's not only VC business, but any business that exists in the economy of this world, at the very end pays everything back to the society, and basically the value is lost at some point. It's even below zero. The return of everything equal is, yeah, really, you don't believe me, but this is already was checked, yes, and probably you can find some interesting reports.
Discuss later.
Yeah, sure.
I know that one.
Yeah, that's right.
Yeah, so I don't know. I hope. Yeah, I answered the questions. Okay, thank you. All right, thanks, guys. And yeah, everyone.